Okay, it's already 11. Good morning, everyone. May I ask if all of you can hear me? All right. Good morning, everyone. So, so happy to see all of you here today. So, can you see the screen? Okay. So let's get started. So happy to see all of you here. So thanks for spending the weekend with me, and also special thanks to MDEC for organizing this event to help promote science and technology to young Malaysians like you all. So first, let me introduce myself. So my name is Khoon. I'm an associate professor from the Department of Computer Science, Faculty of Information Communication Technology, Utah. So today I'm going to give a talk on machine learning systems and and show you some steps on how to build machine learning systems in a step-by-step manner. Right. So today AI is all the rage. In fact, Andrew Ng, the founder of Coursera, said that AI is the new electricity. So it is everywhere in our lives. So we used it every time we open up our phone, every time we browse the internet, every time we log into Facebook, we're actually using AI without even realizing it. So although everyone knows AI, but most people actually do not really know what AI really is. So what really is AI? And how does it impact your life? How is it affecting the society? So in the following 1 hour, I hope to talk a bit about some of the technologies in AI and hopefully do a demo to illustrate how to build a simple ML machines. Okay. So this is the outline of my talk today. First, I will discuss a bit about what is AI. Then I will draw some parallel between the science fiction movies that we have been seeing and what AI can do today. And from there, I would like to distinguish between narrow and general intelligence. And lastly, as promised, I would show a demo to show you how to build your first machine learning system. So what is AI? So this gentleman over here is called John McCarthy. So John McCarthy was one of the pioneers in AI. So in 1950s, he's the one who coined the word AI, artificial intelligence. So AI is basically, according to him, is the science and engineering of making intelligent machines. It's the branch of computer science that builds intelligent softwares and computer-controlled machines that is able to think and act intelligently like a human. So here, the main thing is about how do you make a machine to think and act intelligently like a human. So, but this is a very broad term. What do you mean by human intelligent? What makes a human intelligent? So to do that, we need to dissect what intelligence really means. So humans are said to be intelligent because we display certain characteristics. So for instance, human can reason. So for instance, given some existing statements about the world, for example, all flowers are beautiful. And another statement, rose is a flower. From there, human can make an inference and perform reasoning and conclude that rose is beautiful too. So this is reasoning. And there is a branch of AI that actually do this, which is called logic. Okay, so logic basically is the science of making logical inference. Then humans are also good at solving problems and planning. So given a problem or puzzle, for example, a chess or a business, we want to do some planning, devise strategies in order to solve the problems. We want to win the chess, and we also want our business to be successful. So there is a branch of AI that is called search and also reinforcement learning that allows us to do just this. So search allows us to search for solutions to solve the problem, and reinforcement learning allows us to find the best states that will lead us to the our goal. So as human also, we also display the capability to learn. So we learn by looking at examples and also our past experiences. So once after we learn, then the knowledge that we gain from learning will then be applied to the task that we learn. So in this sense, right, humans can accumulate new knowledge and solve new problems. So there is a branch in AI that do just this, and it's called machine learning. Okay, so machine learning is the branch in AI that actually performs learning, given examples. And also, human are also highly perceptive. Human is able to perceive and understand the world. And it turns out that this process is actually very difficult. Vision is actually a very complex process. It's only recently, in the recent past 10 years, in the 60 years of history in AI, that computers starts to be able to recognize objects in an image or in a video. And the branch of AI that do that is called computer vision. Okay, this is the field that my research lies, and I have studied a lot on vision algorithms. And then human can communicate through languages. This is also a mark of intelligence. In fact, the other day I was watching a documentary on National Geographic, and they were looking for signs of intelligence in our prehistoric ancestors. So one of the signs that hints the beginning of human intelligence is the ability to express themselves in abstract terms such as languages, in art form, or in burial ceremonies. So this is unique to humans and not found in animals. So, and even for science, we devise mathematics. We devise different types of models to represent the model. So the ability of human to model, to represent, to understand complex and abstract ideas is a sign of intelligence also. So here in AI, we have a field called natural language processing, or NLP, that actually studies this and tries to understand the abstract world of languages. Okay, and that is NLP. And last but not least, humans are capable of performing complex motion such as walking, jumping, playing basketball, dancing, so on and so forth. So the branch of AI that does with this is called robotics. So from here we can see that what the things that define human intelligence are basically the things that equally define a machine intelligence as well. And there are different fields in AI that actually perform these things. All right. So you may hear about terms such as AI, machine learning, deep learning, and data science. So are they the same thing or are they different? So here I would like to ask for your participation and ask for your insight into what do you think about these four terms? Are they referring to the same thing or are they referring to different things? So here I will paste this link into the chat box. Can you try to fill up the survey so that we can see what is the general opinion about these things? Oh, wait for 1 minute for you guys to do that. So just click on the link in your Google Meet. In your Google Meet, right? I paste the link here. So just paste on this Google form, and then there are some questions that ask you what is your opinion about all these different terms. So I would like to see what is your understanding about these terms: AI, machine learning, data science. Yeah. One of the many AI techniques, yes. And And quite a lot of you think that data science is a subfield of artificial intelligence. And one of the many deep learning techniques. So the correct answer would be number 3 and 4. Okay, so machine learning, deep learning, and artificial intelligence are basically different things. It's not really. Machine learning is actually basically a subset of artificial intelligence. Machine learning is one of the many AI techniques. Yes, this is correct. Machine learning is one of the many deep learning techniques. Machine learning is, oh, this is wrong. Actually, in the end, only this one is right. Okay, the others are wrong. All right, so let's go back to our presentation. And this actually is the slide that sums out give us the answer to this. So basically, AI is actually a very broad term. It contains many different types of techniques and different types of fields. For example, vision, robotics, planning, forecasting. These are search, robotics, sensors, NLP. These are basically AI. But machine learning is actually much narrower. It's actually a term, is a kind of AI techniques that deals with learning. Okay, so in other words, machine learning allows you to learn from example. So ML is the main characteristic about machine learning is that it allows you to learn from examples. So it's a technique that where you build your system by letting the machine see examples. That is machine learning. But there are other branch of AI that does not do that. For example, search algorithms may not be able to, may not be doing that. And there are certain types of vision techniques that is not based on learning. It is based on a certain kind of model about the world. So machine learning is really not equivalent to AI. AI is actually a broader term. Machine learning is one of the many techniques of AI. And then deep learning that is all the rage today is, excuse me, is basically just one of the many arsenal algorithms that exist in machine learning. Deep learning is by far the most successful ones to date. So it is in the olden days, right? It is known by the term neural network. So deep learning is just neural network. It's just one of the many techniques available. So before deep learning, right, 10 years ago, most people is actually a support vector machine. This is another machine learning algorithm. So deep learning is just one of the many algorithms, machine learning algorithms that is available. Right. Then how about data science? Now, data science is basically the science of processing and analyzing data. So it combines the fields from different domains. For example, the application of mathematics and statistics to analyze your data. Then you have computer science, where it contributes the tools as well as the algorithms for it to analyze the data. And also it has elements of domain knowledge and business knowledge, where you applied the data science to perform certain tasks, for example, to make business decisions. So we look at this, right? Visualization may use some of the machine learning techniques, but it may not. Data preparation is also part of data science, but it's not really a machine learning algorithm. When you mine some of the data to get useful information, that's a mining process, not really a machine learning process. And some statistical analysis that you do is not really machine learning. Those are mathematics. So you can see that data science is the application, is the field of science that deals with data, and it may use some of the machine learning techniques to build models that are useful to perform inference. Okay, so hopefully from here you have some idea about the difference between AI, machine learning, deep learning, and data science. Okay. So in the following, I would like to sidetrack a bit and talk about some of the science fiction and AI today. So I would like to show you some of the old sci-fi movies that dates back 20 years ago. So I watched them when I was about most of your age, when I was still young and energetic. So at that time, these sci-fi movies really blew our mind. And looking back, we find that many of these technologies that is portrayed in these movies is already existent today. And it is actually working exceptionally well. So here is the movie, the first movie of today. So this is Terminator 2 Judgment Day. So Terminator 2 is a movie about Skynet, the AI system taking over the world. It took control of the US nuclear stockpile, and human was on the verge of extinction. But then Skynet met with heavy resistance from the human. And in order to end the resistance, what Skynet did is that it sends the Terminators to terminate the human resistance, John Connor. And then John Connor in turn also sent Arnold. I guess most of you know Arnold, right? He's the governor, the ex-governor of California. He was an actor. So he was sent to save, he was sent by John Connor himself to save himself. So this is a scene from Terminator 2. So look at this, right? There are a lot of technologies in these movies that is already existent today. So this is the beginning where Arnold first arrived in the present. And what is he doing? He's actually analyzing he's actually performing object detection. So you look at this, right? He's actually analyzing the objects that is present. So this is the vision of the Terminator android. So it's actually analyzing, and it finds that okay, this is the motorcycle, is a model Yamaha, and then it's all the information that is available. So today, this is one of the systems developed by a company in Indonesia called Diligence.ai. So you can see that it's doing something similar. Okay, what is it doing? You can see that it's able to detect the car, is able to identify the model of the car, is able to detect the color of the car, the car plate of the car, and the parity, even the parity of the plate. So in some countries, right, certain cars are only allowed to be on the road on certain days. So probably with those with odd parity can only drive on Monday, Wednesday, and Friday, whereas those with even parity can drive on Tuesday, Thursday, and Saturday. So it's able to detect that. And besides that, this system can also detect the logo of the car. So this technology is already available to us today. So let's go to the next one. So somehow when the Terminator was sent back in time, right? Somehow something is very weird about the time machine. Somehow the clothes cannot go through. So the Terminator always arrive in the present naked. So one of the first thing that he do is to find clothes to wear. Okay, so this is the scene where Arnold tries to find. He went into this bar naked, trying to find the clothes to wear. And what does he do? He's actually scanning the person for the and get the body measurement of the people. So what is the body measurement? So these are some things that the Terminator is actually extracting. For example, the inseam, the shoulder, the neck, and the waist. All these body measurements in order to find whether the person body is similar to himself. And then what he will do, the Terminator will do is that he finds the person which has the same build as him, and then from here he will, let me go to that scene. And from here, that once he find the match, right, he will catch this person, and then he will terminate him, and then take his clothes. Okay, so in today's technology we have something similar. So in the following, right, this video shows a product by FX Mirror. which has a 3D virtual fitting room that allows us to try different shirts virtually without having to wear them physically. So this product is already available in some of the supermarkets in some big cities. So it allows it to measure the body measurements in real time, and it also allows the user to switch between items quickly. So this product is actually very useful considering now that online shopping is fast becoming a norm. So when you want to purchase a shirt, right, what is your concern? The concern is that this shirt may look good, but it may not look good on us. So I believe most of us have this experience, right? We see a shirt that we really like, but when we wear it, wow, I look horrible in this shirt. So we want a technology that allows us to wear the clothes virtually. So this is already available to us today. And 3D virtual fitting will be an important feature for online fashion retailer in the future. Okay, and shown here is another product. This is a product by shape scale body. So what you do is that you stand on a device that is a scale. The scale has a rotational arm that will take measurements of your body. Right? And in addition, it also has a traditional camera that takes dozens of photos and stitch them together to form a photorealistic avatar of yourself with very precise measurement. These kind of things will allow the transformation of retail and fashion industry. So it will provide exact measurement of the body and the best size of the shirt that fits your body. Not only that, it can also be used in fitness and healthcare, where you can show your localized lean mass and body fat more accurately than the normal scale. So if you want something more accurate than the 3D body scanner is already available in today's market. And what else? So autonomous machine. So this is a scene from Terminator again, where the Terminator gains control of several cars, and then is controlling the cars autonomously to chase after the young John Connor. So in today's technology, right, it's already available, right? So autonomous vehicle that drives itself is already available, but then much more testing needs to be done. In fact, people look at the economics of it, and then it is the industry is forecast to be worth 24.3 billion by 2025. And two of the countries that are leading in this area are basically US and China. In US, we have companies such as Alphabet's Waymo, Ford is doing another one through Argo. General Motors also is into it, as well as Uber. Then in China, you have companies such as Baidu, Didi, and AutoX. So among the two, right, I think China is the country that is more likely to see wide adoption of the technology first. Why? Because currently there are not many people in China who owns a car, and this means that in China the culture of shared mobility is quite common. That's two reasons. And in addition, right, China has also invested heavily on creating the infrastructure to make it work. So for instance, right, the government are actively installing a lot of 5G sensors along the route. So these are, and the sensors will be used to capture a particular surrounding, and then this data will be fed into all the cars on the road. So suppose that if you are considering that if you are the only car, you only have the local sensors installed in your car, then the issue with this is, right, if there is a truck in front of you, right, the car sensor will not be able to see past the truck. But if you enable a system, a 5G system, where the data can be shared among all the vehicles, so you have an internet of cars. So the internet of cars will share this information among all the cars, and from there, the car will be able to have a correct map of all the cars and all the situation on the road. right? So this kind of system is called V2X. It's called the vehicle to everything systems. It's called the vehicle to everything system. And these kind of systems, right, are crucial if you want to have a wide adoption of the autonomous car today. In US, it has only around 100 V2X projects in the country, but China targets to cover around 90% of the highway with this kind of technology. To do this, 5G sensors is actually critical because it allows fast data transmission, which allows the data to be shared among the internet of all the cars in this internet of cars, right? All right. Then, anyone see this drama before? This is actually quite an old series. It's called it's called the $6 Million Man. So in this TV series, right, the NASA, this is a NASA astronaut, so called Steve Austin. So he was involved in a tragic crash accident involving his space shuttle. So he was severely injured, but then they rebuilt him, and and implant him with bionic arms, bionic legs, and also bionic visions. So in this series, right, he can run at a speed over 97 kilometers per hour. His eyes can have a 20 times zoom and infrared capability, and his bionic limbs have the power of a bulldozer, right? So this particular movie illustrates how how robotics can be used to enhance the capability of a person. And in fact, this is actually one of the field of research. And just last year, there is a whole article on humanoid enhancements in a National Geographic magazine as well. So here, just to illustrate some of the examples of this advancement, this is an example of a 3D bionic arms. So this is Tilly Lockie from UK. So she lost her arms when she was very young, at around 15 months old, from meningitis. So the 13-year-old was the first teenager in Britain to receive a pair of bionic arms in 2016. So in this YouTube video, right? She tried to explain how the bionic arms. So it was controlled by the muscle sensors. So there are sensors somewhere around this part, and then when the muscles here contracts, then the hand will close, and when the muscle reflexes, they will open. This allows her to do quite a number of things. And there are a lot of other research that tries to help the blind as well. So AI is actually working on these different types of area in order to enhance the capability of a human, especially those with handicaps. Then there is also this movie, The Edge of Tomorrow. I believe most of you, this is quite recent. I believe most of you have watched it before. So it's about movie versus alien. And you can see here the human are basically further enhanced with what we call as exoskeleton. This will help human to fight against the physically superior alien species. So with the help of this exoskeletons structure, human stands a chance to fight against the aliens. And this is what we have today. So this is an exoskeleton from Sacros Robotics, and it allows the wearer to lift a total of 200 pounds without even breaking a sweat. And it's fully electrical, and it can run for 2 hours. And if you want to rent it, it will cost you around 100,000 per year. So it's very good for jobs that require a lot of heavy lifting. Okay, and this was showcased in one of the article in IEEE Spectrum. Okay, so hopefully you enjoy all the movies just now, and hopefully you can see that AI is actually creating a lot of interesting advancement in the different fields, and then most of the things that we see previously is now becoming a reality. Okay. So this brings us to the next topic, which is I want to differentiate between narrow and general intelligence. So in the movies, right, we see that a lot of these movies actually involve the story where a machine takes over the world. So here I would like to introduce you to the term singularity. So what is singularity? Singularity refers to the hypothetical point where there is an explosion in terms of this artificial intelligence, where the intelligent agent enters into rapid self-improvement cycles, and they self-improve until they achieve superhuman intelligence, and eventually they conquer the world. So this raises a point: is AI really dangerous? So there are two different opinions on this matter. So Elon Musk, everyone know Elon Musk? Oops, sorry. Do you guys know Elon Musk? So Elon Musk was, is the CEO who believes that in the future robot, but then there's also some opposing voice. The Elon Musk doomsday AI predictions irresponsible. And this is kind of thinks that AI is just a tool and far from being achieving super intelligence. So here I would like to ask, whose side are you on? Are you on the side of Elon Musk, or are you on the side of Mark Zuckerberg? So probably let's do a survey. Can you try to see whose side are you on? So I've posted the link on the chat box. So let's see who are you on. Do you think that AI is an existential threat to human, or do you think that it has been over exaggerated? So let's see. Oh, it seems that most of you agree that AI poses an existential threat to human. Okay. Wow. Okay, around 80% of you believe that AI will pose an existential threat to human, and most of you agree with Elon Musk and Stephen Hawking. And then only 20% of you, actually less than 20%, thinks that the danger AI has been over exaggerated. All right, cool. So my own take on this, I'm with Mark Zuckerberg. Okay, I'm with Kai-Fu Lee for reasons that I will expose later. So in 2011, right, massive earthquake struck Japan, and then Fukushima nuclear plant was devastated. So in this situation, right, it is impossible for human to enter the site. So the only viable solution is to send robots, to monitor what is going on and to do the cleanup. And what happens if you follow the news, right? Some people actually suggested to send in Asimo, which is a very famous robot by Honda. It can climb stairs. Okay, it can do very many tricks. It can climb stairs. It can walk. It can run. It can dance. So a bunch of robots were sent into the site, and what happened is that Fukushima now become a graveyard for robots. It was a humbling experience because it turns out that many of the robots failed to perform their tasks. And many of these autonomous robots actually broke down. They were trapped by obstacles. They get disoriented when the network connection was lost and when they go into a certain chamber. And now Fukushima is a graveyard for a lot of robots. So, but still robot is the only way to do that. But the disaster really highlights the limitation of the current our advancement of technology, and it forces Honda to review its approach towards robotics. So rather than focusing on entertainment humanoid, right, they are actually building disaster robots these days. So since 2011 on making robots work. So one of the effort is basically this DARPA 2015 Robotics Challenge. This was after the Fukushima very well in the disaster area. So they can try to bring robotics to solve problems that can tackle emergency response, such as driving cars, opening doors, and climbing robots. And the result of the competition, right, was actually quite humiliating. Okay, I think that should be enough. Basically, although we see from YouTube a lot of impressive stunts done by robots, by Boston Dynamics, for instance, and then we can see how Asimo walks, runs, dance, and the state of the robotics today is still not very good. In fact, the competition showed that most of the robots are really useless in handling disaster. So simple things like opening a lock is actually a very complicated task that humans can do, but robots cannot do very well. And most important, cannot handle unpredictable situations. So for example, when the robot, you let the robot walks in an uneven surface, for example, in a loose sand, you find that it loses balance very quickly, and then it will fall down and it's unable to get up because it was not trained to do so. So here I hope to bend the idea that AI now is fast approaching singularity, which is by today's technology, which is we are still many revolutions away from that. So we have been it has been 60 years since AI started, and until now we have only around one really big breakthrough in technology, which is the deep learning. It would take more than a dozen such revolutions before we can reach singularity. So we are very initial stage of developing a truly intelligent system. So this brings me to the second topic. You can classify AI into two types. So the first type is what we call narrow intelligence. So narrow intelligence are basically goal-oriented agents that is able to perform autonomous driving, playing Go games, face detection, and diagnosing diseases. These are basically systems that is basically given a particular task. So these kind of agents, these kind of intelligent machines, right? They are very good at the things that are trained to do, but they do not have the intelligence that beyond the things that they are trained at. So we call this narrow intelligence or weak intelligence. What you are really seeing when people meant about existential threat is they are actually talking about general intelligence. So in terms of general intelligence, right, we are talking about machines that achieve human level intelligence, that is self-aware, machines that are able to formulate their own wants, their own intention, and machines are able to self-improve. And in this area, actually, there's not much advancement since 60 years ago. So we are now doing very well in terms of narrow intelligence, but not really in general intelligence. Okay, so here's another survey. I'd like to see what's your opinion. So let me copy this to our Google Meet place. Okay. Can you see the can you get the survey, and let's see how do you rate the current state of general intelligence? Is it equivalent to a baby, or is it equivalent to a chimpanzee, a dog, a rat, or not even close to a rat? Let's see what's your opinion on this. Equivalent to a baby, equivalent to a chimpanzee. Okay. How many? Okay, so so most of you think that the AI now is equivalent to a baby, and only one person thinks that is equivalent to a rat, and 12% thinks that it's not even close to a rat. Okay. All right. So this Yann LeCun. So Yann LeCun is basically one of the founders of deep learning. He's the inventor of convolutional neural network. This is statement. He said that in terms of general intelligence, right, our current AI is not even close to a rat. So we still have a long way to go before we are able to this according to Yann LeCun, right? It's not even close to a rat. Okay, to build your own machine learning. So here, I will try to contrast a bit about the difference between computer science and in general and AI to develop this digit here. In a conventional computer science approach, right, what you do is that you have a programmer here, and then this programmer will basically spend the time working on the program that is able to take this image and then generate the output, for example, to predict, okay, this image contains the digit 8. But then when you given another task, right, then you need the programmer again to write another program, and basically based on the properties or attributes for each of these different flower, it is able to tell me, okay, what kind of flower is this? Oh, this is basically a versicolor type of iris flower. And given yet another task, again, you need another programmer to sit down and write yet another program to detect what, if given this particular email, science programming, traditional programming are used to develop their systems. So for every single problem, you need to write a different program to tackle it. But there is a problem with this kind of technique. Why? Because there are a lot of problems that are basically too complex to solve using our current technique. So for example, given the car here. So for example, if you want to write a programs that can detect a car, right? What you may do, right, is, for example, okay, let's we can detect a car if, for example, if we detect, say that, okay, this region of the image contains the mirror, and if I detect this particular location contains a wheel. So you write an if statement. If this part, if this location is a mirror, and if this particular location is a wheel, then what you do is you output a car, right? So you may write this kind of rule-based algorithm to like detect whether it's a car or not. But this kind of traditional way of programming is actually very fragile. So for example, right, when you write a program that operates in this, right? So if you look at this particular location where you indicate it should be a car here, right? A car, you may not, the system will not be working. So it will say that this is not a mirror, because of that, this is not a car. So traditional programming cannot handle, so that here there are two problems with traditional programming. The first is that it cannot, you have to write different programs to solve different problems. And secondly, there are some problems that are simply too complex for traditional programming to solve. So because of this, we want to rely on machine learning approach. How do we do machine learning approach? So in the machine learning approach, right, what you do, rather than writing programs for different different problems, what you do is you let the computer see the training samples. So all you need to do is basically to collect the training samples. So for example, here you collect a lot for digit classification, you collect a lot of samples with different labels, right? And through this to the machine learning algorithm, and let the machine learning algorithm see the training samples. And from there, the machine learning algorithm will generate a model that defines the problem. Now, then for another task, similarly, what you do is you collect training samples pertaining to the iris classification problem, and from there, you throw into the same machine learning algorithm that will generate for you an iris classifier. So similar for span classification. So this is the difference between computer vision, traditional programming, and the machine learning approach. In the traditional programming approach, what you do is that you need to write a rule-based algorithms which is specific to the task. For every single task, you need to write a different programs. But for the machine learning approach, you can see that the algorithm that you use are the same. What you need to do is you only need to prepare the training samples and build a model by letting the computer see the training examples. So you build the system by letting the computer see examples rather than you program the program itself. So this is the machine learning approach. And this is what we'll be doing. Probably I'll skip this in the interest of time. So this will be what I'll be doing later. So I will try to work on a problem for tumor detection. Okay, so given these X-ray images here, what we'll do is we extract two properties. This is the height. We also extract the width. Okay, so we extract these two properties. So the input to our machine learning algorithm is height as well as the width of this particular region that indicates the tumor. And the output is whether this particular tumor is malignant or non-malignant. Okay, so the input to the model, right, is basically to our machine learning algorithm is basically the height and the width, which is indicated by this part here. And the machine learning will learn a model that is able to detect whether this particular tumor is malignant or non-malignant. So this is what we are going to do. Okay, so for those who wants to follow the practical, you guys can follow me. Excuse me, yeah. So right, so first you go to Google Collab. Okay, click on GitHub, and I've already created the GitHub a code that performs just this. Okay, so it is in this particular okay, this particular GitHub. I'll paste it into the meeting place. Okay, so you can follow me if you want to. So basically, just go to Collab. Okay, so click on this Collab. Then this particular place, you will come to this website. Then click on GitHub. and then paste your demo, the GitHub page here, and then click on this tumor classification notebook. Okay. So the first step, is to load the data set. Okay. Now, and we want to try to understand. So the first step is to load the data set and try to understand the data set itself. So we have this code here. So just run this particular code. It says that this notebook was not altered, but also run anyway. What this code do is basically it will try to download this tumor.csv file. It's just a comma separated version, and it contains all the training samples for training our tumor classifier. Okay, and then once I've done this, right, if you type ls, ls means that some things I want to see what is in my directory. So tumor.csv is in my directory. So I have this particular file in my current folder. After you have run this particular code, wget this particular file. So this will be in your current folder. So let's load this folder. So to load this, right, we will use the Panda library. So import pandas as panda. So pandas is basically a library that is normally used for by a lot of data scientists. So you can use panda to load the data set and do a lot of pre-processing on the data set. For example, you can use panda to load different formats of the file. You can use panda to do some filtering. You can use panda to check for missing items, to transform the data. You can use Panda to do different things. So here I will import the pandas as PD. PD here is just the name of this library, and I will read the CSV file. Okay, so I read tumor.csv and I'll load that as data. Okay, so this I've loaded this data. And let's see what we have. So I'll run data.head. Data.head will actually, what it will do is that it will show the first 5 items in my data set in this CSV file. So here I have 3 columns. The first 2 columns are the width and the height, and the third column is the malignant. It's the malignant column. So these two is the width and the height of a particular tumor. Each row is one tumor. This is the tumor of a first person. This is a tumor of the second person, the tumor of the third person. So basically, the data set contains a lot of data that is collected by the hospital from different patients. Okay, and this patient has this tumor, and this tumor is 25 centimeter. I don't know centimeter or millimeter, and it is not malignant, benign. Okay, and this is the tumor of a second person. With this height and this width, and this one is malignant. Okay, so once you have done this, then let's go to the second step. Okay, we need to prepare the data. So to prepare the data, we have this particular data being loaded. So what we need to do now is we need to extract the input from the output. So this would be the input, we call it X, and this would be the output, and we call this Y. So in the next section, I will write the code to extract X, which consists of these 2 columns, and the Y that contains the third column. Okay. So let's split the input and output. So I get from data, and in the data, I will get these 2 columns, which corresponds to the width as well as the Okay, and after I get this, I will use dot values to convert into another form, and I will use y to get my capture my data for the pipetted values. Okay, so this will get me the two my input and output, so x and y. So from here, right? So what I've done here is these two lines of code is basically capturing the first two columns and put into x, and you get the malignant column and put into y. Okay, so let's visualize what we have done. So I've created this function so that you can show it. Show samples x and y. Let me run this. Followed by this guy here. So this is the samples that we have. Each of the dot here represent one page a tumor, okay, and the red represent this is malignant tumors that are dangerous, and the blue dot shows the tumors that are not malignant. So our task now is to build a model, use machine learning to perform this classification. So probably I'll split the training and testing part and go straight away to train the model. So the next step that I want to do is I want to train a model that is able to differentiate between malignant and non-malignant items. So how do we do that? So if you say we want to train a model, right? What we are really training is basically we are training. There are many different types of machine learning algorithms that we can train to be able to perform this kind of detection. For example, just name you a few. So for deep learning, you can use deep learning. You can use logistic regression. You can use SVM. You can use KNN. And many other types. So there's a wardrobe of machine learning algorithms that you can use. So for this problem, I'll use the logistic regression. Okay, so let's see how to build a machine learning algorithm to perform this. All right, so here to train a classify modifier, that's from sklearn.linear model import regression. Okay, so here I'm using this library called logistic regression. It's part of the sklearn library. It's a machine learning tool. So what I'll do is I'll create a model of I call it my model. Model is equal to logistic regression. Okay, and what I'll do is I just take the model and I just fit the x and y that I've done. So this is it. This is the only code that you need to write in order to build a model. So what I do is I create this model, logistic regression model, and I let the model see this training sample. So .fit you can imagine as though it's just letting the model see the training that we have seen. So x is the input and y is the predicted value. So let's run this, and this will train the model. It's just as simple as this. You create a model, and after you created the model, then you feed it. Fitting means that you let the model see these training samples, and from there, the model will learn the required parameters that define the model. All right. So once you have the model, then the next step is you want to evaluate the model. You want to see how well your model is doing, right? So here is the last stage where I evaluate the model. So what I'll do is I'll take my model and I predict, and you can throw in the original samples that I throw in to get the prediction. So this is y predict. So I'm going to throw the samples in x, and I'm going to predict it and will get the value of y. So let's run this. So it's just one line of code, and then you'll be able to predict the value. All right. So it has already predicted the value. So let's try to see the result of the prediction. And from here, these are the prediction for sample 1, sample 2, sample 3, sample 4. So it's just another one line of code to do the prediction. Right? So this is one line to train a model, one line to use it. Okay? And then from here, we want to see how well does the model perform. So you want to compare the performance of your model, your y predict that you get from your model, and you want to compare it against your test data. so that you see how well your model really do. And that is what we call as model evaluation. How well does is my model really doing as compared to the actual value? So to do that, again, I need to import a library called accuracy score. And what you do is you just print for this function. And then you throw the values that you have already, you get from a model, which is y predict, which is the predicted value, the y-test, which is actually the real value of this, and then it will, not really y, it's called y, sorry. Y, which is the real value of the y, of all the samples, and then you get that the accuracy is around 80%. Okay, meaning that 80% of the samples are being modeled correctly. And what we do, we are really building is basically a decision boundary. Sorry, yeah. What you are really learning is actually a decision boundary. Oh, somehow this is not working. So what you are really learning, sorry that the visualization is not working, but what the model is really learning is actually learning a decision boundary. So just to show you what it means, so here you have the width and the height, and you throw it to this guy here, and the model will tell you whether it is malignant or not. So 1 means it is yes, 0 means that it's no. So what is this model really training? It's actually learning a line. It's actually learning a line. So this is the model that is actually learning when we fit the training model. So when we call the fit function in the model, by model, right? What we are really doing is that we actually try to find the line that best separates between the two items. Okay, so this is a very fast introduction to machine learning, and as you can see, right, the code that we need to write is actually not that many. So the code would be just the code that is how many lines do I need? I need a line to read the CSV file. I need a line to I need one line to read the file. Then I need another 2 lines to split it into X and Y. Then I need 1 line of code, 2 lines of code to build the model. And I just need 1 line to do the prediction. So each step only 1 or 2 lines only. So it's actually quite simple. All right. So I guess that's all I want to say today. It's already 12 o'clock. I hope that I have more time, then I can go through the steps really carefully for you guys. So before we end the talk, may I know if there's any questions from the audience? So if no, then thank you for attending the talk. I hope that all of you learn something from today, and I hope that you guys are able will be interested to learn computer science and AI in the field. There's one important thing that I miss is that AI is going to affect a lot of job opportunities in the future. So a lot of routine jobs, easy to do things will be eliminated by AI in the future, and we are already seeing it in a lot of countries already. All right.
Dr. Tan, there's a question.
Yes.
In chat. There's 2 questions in chat.
How I have the sign of what is the model and poly? Oh, okay. Model is basically the model, you can think of it is like a piece of software that you can call, and it will give when you give in a certain input, it will produce the output that that perform the task. So for instance, right, Let me. So a model, right? You can think of a model as a black box that receives a certain X and then it will produce a certain Y. Okay. So it is actually how should I say this? It's like imagine that you have an oven now, and for this oven you can use it to bake different types of food, right? You can bake different types of food. So what you do when you want to train, when you are training, right? You you look at what are the recipes for generating very tasty chickens. So for example, you have this type of parameters about the chicken, the size of the chicken, and then you may have things like the besides the size, the type of the chicken. You can also have like the age of the chicken, different parameters. And then from here, you want to predict whether this is tasty or not. So imagine that your model is something like a microwave. So what you're really learning, right, is you are trying to learn the parameters of the microwave that generate a very tasty chicken. So for example, right, what are the things? For example, what is the kind of temperature that will be required? What would be the heat? What is the duration? So when you're training a model, you're like actually learning the parameters of that particular model. So something similar to the temperature, the heat, and the duration, the properties that define a microwave. So when you're training the model, right, you're training the best parameters of the model that produces the result that you want. So that is actually a model. The different settings of the temperature, different settings of the heat and duration, you can use it to produce different types of food. So different types of food, you will need different types of parameters. So for example, the microwave, you can train a microwave to generate very tasty chicken. You can also use the microwave to generate very tasty, to develop pizza. Each of these different types of model, right, will requires different types of setting. So what you're training the microwave to do is the settings that is required to generate these different types of very tasty foods. So that would be one way to imagine that. All right. So hopefully you get a sense of what a model is. So a model is basically some parameters of the setting of the model that you can tweak. So when you have certain values, it will perform in a different way and will be good for different tasks. So hopefully that answers the first part of the question. What is the other things? What is a model? So I think I've already answered model. What the model really is. How to reduce the RMSE score? So RMSE score is basically what we call the root mean squared error. It is basically a measure that that is used to determine whether a model is working very well or not. So it is computed by comparing the predicted value and the actual value, the difference. So if it is the predicted value is very similar to the actual value, then the RMSE score will be low. So in order to reduce the RMSE score, you need to train the model properly. By training the model properly, meaning that you have to set the model, you have to use the correct optimizer. Optimizer are the main engine behind the machine learning algorithms that finds the best solution for the model. Okay, so you need to use the correct solver and the best machine learning model. So for example, in the microwave example, right, you need to find the correct brand of the microwave, right? Similarly, you need to find the correct machine learning algorithms, and you need to also find the best setting. So in order to find a good setting, right, what do you need? You need enough data, right? You need to use enough data. So you need to do a lot, collect enough samples, and then you need to be able to use the correct algorithm that will be able to find the best algorithm, to find the best parameter values. So those are some of the ways that you can use to reduce the RMSE score. Okay, so any other things? So if there are no questions, then that's the end of the talk. Thank you for attending. I hope that all of you learned something today.